Okay, we're on to question 6, the final question in the concepts and skills parts, the short questions. So let's have a look. Some people will be delighted to see this, and other people not so much. It's a theorem question. Prove that if 3 parallel lines cut off equal segments on some transversal, then they will cut off equal segments on any other transversal. So, as I said, some people will know this. They'll be delighted to see it. They might even do it as their very first question, whereas other people won't have learned it and it kind of be ruled out from it. So what we're given is that S and T are transversals of 3 parallel lines cutting and crossing at A, B, and C, and D, E, and F respectively. So cutting through S at A, B, and C, cutting through T at D, E, and F. We know that AB is the same length as BC. We're told that. Okay. We're asked to prove that from D to E is the same as from E to F. So we're asked to prove that these two lengths are the same. So with that in mind, well, we're going to start off, and we're already on 4 marks, by the way. Our construction, you can do this construction in different ways. You see it done in different ways in different textbooks. But what I'm going to do here is this. I'm going to draw A to G and B to H, both parallel to T, meeting the other lines at G and H. And I need to mark the angles 1, 2, 3, and 4 as shown. Okay. So those are my 4 angles that are marked. Okay. My construction is now complete. I'm up to 8 marks. I'm now going on to my proof. I want to consider the triangles ABG and BCH. Okay, so I'm considering these 2 triangles here. So I'm examining these. Now, in this case, I'm going to look at my angles. I'm going to say angle 1 is equal to angle 3. You can make out the F shape there. These are going to be corresponding angles. So maybe I could have used a better color pen to show this, but you can see the F shape here. That'll be a better way of showing that angle 2 and angle 4 are corresponding. However, there's another F shape in here using these 2 sides, and that would show that angle 1 and angle 3 are corresponding. So in this, that's our starting point here for our proof. We're going to then say that AB is equal to BC. We're given that those 2 lengths are the same. I can say angle 2 is equal to angle 4 for the same reason as the first part, corresponding angles. Therefore, these 2 triangles are congruent by the fact of angle side angle being equal to angle side angle. Those 2 triangles are congruent, meaning I could chop one out and place it exactly down on the other. We're up to 12 marks. We keep going. We can then say AG is equal to BH. So these 2 sides are equal to each other because they're corresponding sides in the congruent triangle. They're equal to each other. Now what I have is I have ADEG and BEFH are both parallelograms, as AG and BH were both made parallel to the side T. So these now are parallelograms. And what do we know about parallelograms? Well, we know in parallelograms, in this case, you can see which sides there. The arrows are showing the parallel sides. And we know, of course, that all 3 of these are parallel to each other. So therefore, I can say, well, in a parallelogram, opposite sides are equal and opposite angles are equal. So AG is equal to DE, and BH is equal to EF. But because, of course, now that we know that AG is equal to BH, I can then say, of course, that DE is equal to EF. QED, it is proven, and I'm up to my 15 marks, my full marks. So as you see, once you know it, it's straightforward enough. But of course, you're not going to come up with it yourself on the day, so you have to practice it. Okay, Leads us on to a different part of the question. A yacht club is designing a new flag. The flag is to consist of a red triangle, AEF, on a yellow triangular background, ABCD, as shown. AB is 8 units. AD is 6 units. E and F lie on BC and CD respectively. X units from B to E and from C to F. So both this distance here is X and this distance up here is X. Show that the area of the triangle is given by area equals 24 minus 4x plus a half x squared. Now, there might be different ways to go about this, but I think the easiest way is this. You've got to find out the area of all the yellow triangles as such. So we call this one triangle 1. So I'm going to find the area of this one. Of course, it's a right angle triangle. So the area of triangle EDF is a half times 6 times 8 minus x. Triangle 2 is going to be a half times x times 6 minus x. And triangle 3 is going to be a half times 8 times x. When I add up those three triangles together, okay, I can factorize out the common factor, which is x, multiplied through everything else, and you're going to get 48 minus 6x plus 6x squared minus x squared plus 8x. That's going to be 24 plus 4x minus a half x squared. It's exactly what we want for the answer. But of course, actually, well, it's similar to what we want from the answer. But of course, we must go one step further because we know the area of the entire rectangle is 6 times 8. It's 48. From that 48, I'm going to subtract what I have here. So when I subtract it, all the signs are going to change. And then I do get my final answer, 24 minus 4x plus a half x squared. So that part there is worth 10 marks. And we now have the area of the red triangle. And there's one last part to this question. It says, find the minimum area of this triangle. So the minimum area of the triangle, well, we have our formula for it, our function, basically. Now I can say the area is a function of the side length x. Well, if we want to find a max or min, what do we always do? We get the first derivative. In this case, we'll have minus 4 plus x. We solve equal to 0. So if the minimum is going to occur, the turning point is going to occur when x is equal to 4. So what do? I go back, I put the 4 into the original equation, and I get 16 units squared. 16 units squared. We don't have centimeters or anything like that. So it's 16 units squared for our minimum. So a relatively straightforward differentiation. And one thing to note is that you could have gotten full marks for part 2 without getting full marks for B part 1 because you're given the formula already. And that's something to always look out for in these questions. Okay, so that is the end of our context and applications questions. Our concepts or skills questions. And now we're on to the context and applications, our long questions.